Okay, we're recording, and to those who are new to our sessions, I think I saw a couple of new names. Welcome. So yeah, that was a very fact-dense session, I think. If we want to discuss every question that I've got, it would take about 10 times as long as the video took. But let's go for it and see how far we can get. So who's going to start the ball rolling with a question? Anybody?
Eric, I was just wondering, I've just read an article about Neil Turok. I think he's currently at the University of Edinburgh, and him and his team have been working on a new theory of the universe, a mirror universe. And I'm just wondering if that might, they say they don't have any proof yet, but I was just wondering if that might solve the problem of some of the asymmetries.
Yeah, I don't know how new the theory of mirror universe is. I thought that had been coming along for a long time. But I mean, Neil Turok is a genius. He was chief of the Perimeter Institute at one stage, I think. So yeah, perhaps if you can give us a link to more information on that. I think I have seen it somewhere a while back, something like what you're talking about, but I never went into it. But anything he does is always very interesting. Yeah, and of course, he's South African, by the way. South African born, at least.
Okay, I'll try. They've got a series in the New Scientist at the moment devoted entirely to space research and theories of the universe. I'll send you which copy.
Great, thanks. All right. Okay, so yeah, exactly what parity is, exactly what Noether's theorem is, and how it works. These are all questions I've got, and there are several things which are just mind-boggling to me. I mean, when they say, yeah, this everything was combined at 10 to the minus 46 of a second, and a long time later, 10 to the minus 30 something. I don't exactly regard that as a long time. In fact, I regard it all as a fraction of an instant. So yeah, I don't know what you guys thought.
Derek?
Go ahead.
Hello?
Go ahead, Peter.
Okay, just a couple of questions here. First of all, you're talking about those fractions of microseconds. And to me, those are actually rather meaningless because we can't really imagine those times. And surely time is relative at any stage of the universe. Is that right or wrong?
Sorry, say that again, surely?
Well, time is relative to any stage of the universe. So those fractions of a second, but I don't know, it just seems to me to be relative to the stage of the universe, or whatever it's relative to. Yes. The time is meaningless, certainly in our minds. 46.
Well, it's of a scale which is meaningless to us, but I suppose if you're a string, or if you're even a neutrino, then it becomes more meaningful because you're on a different scale.
Yeah, unfortunately, I'm not really capable of expressing myself on that subject. Now, the next thing is, at one stage, they were talking about in the beginning, the word was God, and it was God.
Yeah, I don't like it when they start with Bible quotes on a subject like this.
The universe was perfect. Now, if something is perfect and therefore symmetrical in every way, it must stay so unless a factor is introduced from without. Am I understanding that correctly or not?
Yeah, it's a bit of a sort of a grey, hazy area, but I mean, this is what the whole session was about, really, in these symmetries and the fact that neutrinos are only right-handed, is it, or left-handed? I'm not sure, and things like that. Yeah. So just a reminder again, I do have the transcript. If it helped me a lot to actually make up the transcript, because then you're forced to go through a thing one at a time. Otherwise, the facts just shoot through the brain a little bit too quickly to absorb. So I think probably this video, to get some decent sort of sense out of it, you need to view it a few times probably.
Derek?
Hello?
I maybe just be illustrating my ignorance, but if everything that is in the universe is a result of this break of symmetry, then if it didn't break, the universe wouldn't exist. So is perfection a good thing or a bad thing? Because if it was perfect, and maybe there was nothing.
Yes,
and we had,
well,
yeah, so
exactly.
to me there's a contradiction within this, but it might just illustrate my lack of understanding.
No, it's quite correct. This is the sort of conclusion that people have come to, that scientists have come to, is, if there had been exactly the same amount of matter as antimatter, then everything would have annihilated. There would be only energy left. There would not be nothing, but there would be no matter.
Yeah.
There would only be energy. So, yeah, I mean, the whole thing is that everything should be conserved. So in that imbalance, which caused some matter, 1 part in 1 billion left behind of matter that we know, that the difference that's the difference that was caused there, that it's got to be somewhere. So I don't know. I don't know if I can't remember what he said in the thing, whether there was something that, if it's in energy or what the theory is.
No, Derek, just an interesting observation that in the conversion of, or the first instant of things happening from 10 to the minus 43 seconds, by the time we got to 10 to the minus 7 seconds, the gravity, electromagnetism, and the strong force were all established. I just find that very significant that 10 to the minus 7 seconds, is similar to the 7th day in Genesis. That all was formed. I find that quite interesting.
Okay. If you hold your breath for 10 to the minus 7 seconds, I don't think you would notice it. It's quite a small period of time. But also what was interesting to me, he says at that stage, the universe was a balmy 10 to the 15 Kelvin temperature. Now, if you call 1,000 billion degrees Kelvin a balmy temperature, I don't know what cold is. Yeah. So
just the significance of things being settled in a way at that period of time. But Derek, the other observation, I found that a very interesting presentation, very dense, way beyond my level of understanding. But it also goes on to say that we're constantly searching for new sites. There's always something at the end. So it gives comfort to those who are studying at the moment. There's always going to be some work that's going to be necessary. We never seem to get to the full understanding of the universe.
There's an enormous amount that we don't know, and this is what makes it so fascinating and interesting all the time. Yeah, and by the way, one of the things I liked in this presentation was his analogy for light, relating it to somebody having to run along the beach and then swim in a bit of the water to go and rescue somebody. That was quite a bit of an eye-opener for me. So there are quite a few little nubs of things that I found very interesting like that in this video. By the way, I see Peter Foster. I don't know if he's still here. He put in the chat a question that he joined late, and can he get a recording? So if you're listening, Peter, we can just email you the link to the video. It's on YouTube. And then we will also send you a link to the recording of this discussion as well afterwards. Okay.
Terry,
Go ahead.
just another, and again, this is maybe that's a proof of my ignorance, because I had never ever heard of the forces being separated or that they were joined, that they can unify at very, very high temperatures. Never heard of that.
Yeah, well, so, this is fundamental to, I mean, I don't know if Einstein started it, but he thought, okay, there's got to be a unified theory of everything where essentially what that means is one formula would describe everything and would contain, how gravity is produced and how electromagnetic and everything in one formula. But, to do that, all those, if that theory exists and is true and can be proven or deduced, then this is a consequence that at some stage in the early universe, all these forces had to be combined at one time and become separated later on. So it's just a sort of a consequence of the whole process of thinking the thing through.
Eric, can I just add to that?
Yeah, please, Pierre. you
I
can
think in
explain
all the DVDs or discussions of particle physics, there's a very clear line that initially at the Big Bang, all four known forces were combined. And then as the universe cooled, they separated individually. And I think that 10 to the minus 7 that David referred to, I remember as 10 to the minus 12, which is when protons and neutrons were actually formed, which is quite late actually in the history of the universe. If we think of inflation around about 10 to the minus 32 to 10 to the minus 35, I think that is described over there, but it's all to do with the temperature or energy level of the universe. And as it cooled down, the four fundamental forces became separate and became to describe different processes. And then just a final tongue-in-cheek comment. He ended right at the end saying, is the universe changing from perfection to corruption? I never knew that Jacob Zuma studied physics at all.
You have to bring a GNU joke into it, yeah. Yeah, so, okay, thanks for reminding us. That's essentially what happened. It's as a result of the expansion of the universe. It's just a physical fact that when things expand, then they cool down. And when things cool down, then that's what allows things to separate, the forces to separate, and allows eventually what do you call baryogenesis? Baryonic matter began to form. It was able to sort of condense out of the extreme heat at the very low temperature of 1,000 billion degrees Kelvin. So, yeah.
Well, I think we will be arguing about the Big Bang as long as we will be arguing about in the beginning. So there's parity for you.
Yeah, of course.
For...
There's plenty of people that say the theory of inflation has got so many flaws in it. In that period of what is it called? Yeah. And therefore couldn't have happened that way. There must be some other explanation for all the things that it explains, although nobody's come up with a better explanation. And there are plenty of people who think that there was no Big Bang, there was no beginning, it was just part of a cycle, including famous people like Penrose and so on. So yeah, there's plenty of theories.
Stick around. If you stick around long enough, you'll also be famous. So keep it going. Thanks.
So let's see, in 1 trillion years, maybe we'll have the answers. It's a small number when you compare it to the temperature of the universe at 10 to the minus 12 seconds. All right.
Can I just
Once,
say something
sorry.
just quickly before we close and before we lose everybody?
Yeah.
If Cor Rademeyer and Mr. Kervishen care to send their emails through to me, my address, this is Peter Harvey, my address is on the invite I sent around to ASSA. If you send those to me, I shall certainly distribute the material, the links that Derek sends to me.
Yeah, Peter Foster put his email in the chat. I'll just send it to you if you didn't catch it.
Derek, Elaine and I have to leave now, but thank you very much. A really, really interesting
Yeah, that was
presentation.
really lovely. Thank you. Thank you.
All right, enjoy your supper. Are there any more questions before we sign off?
Just a brief one. Aren't there time lapses and time warps in another dimension that we can't see, that we're talking about microns of a second and stuff like that? So
Yeah, I'm not sure what you mean by that.
no, we're always talking about different planes and different wormholes and all these at the moment science fiction terminology or time warp that
Yeah, look,
we don't pick up on.
If we just talk about the video we watched, I thought actually that a very high proportion of it was actually based on pure physics and deduction and scientific principles and so on, which I thought was great. But there was some of it was a little bit dodgy, involved some of the dodgy speculatory sort of theorizing for which there's no proof yet. So yeah, you just have to get into that when you're talking about the origin of the universe. You know, we just haven't been able to do enough science to know everything yet. So there's just stuff we don't know, and we just got to accept that. And there's going to be theories. I mean, supersymmetry is you know, whether supersymmetry is a thing or not. Nobody's been able to find supersymmetric particles. They say maybe, I'm not sure why, but so the symmetric particle for whatever, you know, these ones with the S at the beginning, apparently their masses are much higher or something, and therefore much more difficult to find in a larger LHC because it requires incredible amounts of energy to create these particles. So maybe, so that's what, you know, the proponents are saying. They just haven't been able to create the energies to find them yet. So, but I mean, in that case, you know, if we can't make them, then do they exist? I'm not sure. I don't know. But I know Sabine Hossenfelder is a great sort of skeptic about the supersymmetry and all those things.
Thank you very much. Bye.
All right. Sorry, that was just a general comment.
Thanks.
Yeah.
It's very thought-provoking talk, and I'm looking forward to reading the transcript.
Yeah, yeah.
My leisure.
I
Thanks,
found it
Derek.
very useful. Okay. All right. Any more? All right. We'll see you next time, and thanks for attending. We will end it here then. Thanks. Cheers. Bye.
Cheers, all.
Okay, Peter. I'll
Thanks,
send you
Jerry.
the attendance, but
Thank
I
you, everyone.
presume you have it.
Thanks very much. I've no